So this is lesson 3, and we're going to talk about something that's not in your note packet today. So what I need you to do is get out just one sheet of paper. I'm going to review some important things that you need to know about graphing. And next week in class we're going to be doing a graphing lab and some graphing practice, and then we'll start with the microscope. So why do we graph data? Well, we want to show the relationship between something. And we want to interpret our data. So a lot of times we do an experiment and we collect data. We can graph it, and that helps give us meaning about the data that we collected. The first thing that you need to do is determine your independent and your dependent variables. So that's the first thing that you need to do, and you need to create a title that includes the both independent and dependent variable. Well, we've been doing that with our matrices. We have been creating a title for our matrix that includes the independent and dependent variable in some type of population. So you're going to basically do the same thing. So the relationship between the number of blowflies on a dead body and the time since death. Which variable is which? Meaning, which is my independent variable? I just want you watching right now. You don't have to write anything down yet. Independent variable, and which is my dependent variable. Remember that the independent variable is something that you, the experimenter, has control over, meaning it's something that you can manipulate or change. So, can you change the number of blowflies on a dead body? Probably not, but you can certainly change the time, okay, how many days that you're measuring your experiment over. So the independent variable in this case would be time, and the dependent variable is the number of blowflies. Okay, so what I do want you to write down on your piece of paper is independent is plotted on the x-axis. That's the horizontal axis. And remember, it's what the experimenter changes. And then your dependent variable is on the y-axis. And that's the one that's affected by the independent. Now you're going to label your axis, and you have to make sure to include units. So we said time was on our x-axis, and the number of blowflies was on our y-axis. Now time, we have to have units here. We just wrote time. That's not good enough. All right? In parentheses, you need to put days. Maybe it was minutes. You would put minutes. So you need to have units. For the number of blowflies, we don't need units because it's going to actually be a number. And the number of blowflies over time. Or you could have written this as the effect of time on the number of blowflies on a dead body, if you really wanted to be specific. You can have a long title. So what type of graph are you going to make? Well, usually the directions will tell you whether it's a line graph, a bar graph, scatter. Sometimes you need to figure it out, but most of the time it will be a line graph. Now, how a line graph differs from a scatter or a line of best fit is sometimes you will plot your data and you will get different points. And it might say, make a line of best fit. So what that means is you try to take your ruler and see how many of these you can get close enough to. So your line of best fit might be through there. But we'll do some practice in class, so you don't have to worry about that. Now, the hardest thing that I've seen students have trouble with is the scale. Okay? What they tend to do is, here's their graph, and they do 1, 2, 3, 4, 5, 6, 10, 20, 30. And they make their graph down here. And they haven't used any of this or any of this. When you make a graph, you want to spread out your data so that it fits as much of the graph paper as possible. So there's a really good way to do this. Okay? So you already wrote down independent on the x-axis, it's what the experimenter changes, dependent on the y-axis. Now I want you to write down scaling the axis. Okay? And these are what you do. Find the highest number in the data set. Count the boxes on the graph paper. Then what you're going to want to do is divide the larger number by the smaller number. Okay, and so I'll show you how that works. So you got 3 steps. So we already said that time was over here on the x-axis. So I'm just going to put this in over here. Time and days. You're just watching right now. My highest number is 6. I'm going to count my boxes. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20. So my large, I got 20. So 20 divided by 6 is going to give me about 3, because 3 times 6 is 18. So it's a little bit more than 3. So that means each one can be 3. So I can count 1, 2, 3, and I can put a number 1. I can count 1, 2, 3, and put a number 2. 1, 2, 3, put a number 3. And I could keep going. Okay, and I'll show you what that's going to look like. Now, on my y-axis, we know that it's the number of blowflies, right? My highest number is 60. Notice how it's not the last number. I'm looking for the highest number. And I've got 20 boxes. So I've got 60 divided by 20, which is 3. What that means is that each line can be worth 3. So I can do 0, 3, 6, 9, 12, 15, and I'll have enough to go all the way up to 60. As you see was done here. I went from 0 to 60. Well, now I just have to plot my points. The best way to plot your points is, number 1, you're going to write this down. So you're going to write plotting points. First you put a dot, then you circle it, and then connect the circles. So 0 and 20. Then I've got 1 and 30. Two and 38. Three and 45. Four and 53. 5 and 60. And then 6 and 55. So now I'm going to put my circles around it. And you can see that I've used as much of the graph paper as possible. And then I would take a ruler. I'm going to do this straight hand though. And I'm going to connect Okay, notice I don't bring this to the end of the paper. And then I'm done. And that's it on graphing. We'll do some practice next week.